Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 4 video on the topic of area of a trapezium, where I will solve the problems of exercise 18a from the textbook of author RS Aggarwal. If you have not watched the previous 3 parts on the area of trapezium, then I strongly suggest and request that you please also watch those videos to maintain the continuity of your study on the topic of area of a trapezium. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving problems of exercise 18a on the topic of area of a trapezium. Okay, so I have the problems on the top left corner, and on the right hand side I will solve the problems. I hope the fonts of the problems are big enough so that you can see them properly. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution. Okay, so the first problem says that find the area of a trapezium whose parallel sides are 24 centimeter and 20 centimeter, and the distance between them is 15 centimeter. So it is a pretty straightforward question. So this is problem number 1. Question number 1. So as per my discussion, I always denote small x as the, so if this is a trapezium, let's say in general, I always let's say this is a trapezium ABCD, I always denote the length of the smaller parallel side. So AB is parallel, say AB is parallel to DC. I denote x as the length of the smaller parallel side and y as the length of the larger parallel side, and the height of the trapezium is by age. Okay. So in this problem it is given that x is given to be equal to 20 centimeter, x is 20 centimeter and y is 24 centimeter, and the height h is equal to 15 centimeter. The distance between the parallel sides means the height of the trapezium. So area of trapezium, as we know, the fundamental formula is half multiplied by the sum of the parallel sides multiplied by the height. So this will be half x plus y is 20 plus 24 multiplied by height, it is 15. Since the measurements, the lengths are all given in centimeter, the area will be centimeter square. So this is equal to 44 divided by 2 multiplied by 15 centimeter square, and this is equal to 22 multiplied by 15 centimeter square, and this is equal to how much is 22 multiplied by 15? This is 110, 22. So 330 centimeter, 330 centimeter square is the area of the trapezium. Let me quickly check if my answer is correct or not. Exercise 18a, 330 centimeter square is the correct answer. Okay, let's do the next problem. It says find the area of a trapezium whose parallel sides are 38.7 centimeter and 22.3 centimeter, and the distance between them is 16 centimeter. I won't do this because this is exactly as the problem number 1. So this problem I will skip. This is same as question number 1. Okay. Let's see question number 3. The shape of the top surface of a table is trapezium. So a figure is given. Its parallel sides are 1 meter and 1.4 meter, and the perpendicular distance between them is 0.9 meter. Find its area. This is also a straightforward question. A figure is given where the parallel length of the parallel sides are given and also the height is given, so we can easily find the area. So I won't do this, as this is a pretty straightforward question, same as question number 1. Skipped. Question number 4. Let's see question number 4. It says the area of a trapezium is 1080 centimeter square. If the lengths of its parallel sides be 55 centimeter and 35 centimeter, find the distance between them. So again, it's also a pretty straightforward question. So we know that area will be equal to half multiplied by x plus y, where x and y are the length of the parallel sides and h is the height of the trapezium. So this implies area is given as 1080 centimeter square will be equal to half multiplied by the parallel sides are given as 55 centimeter and 35. So x will be 35 and y will be 55. We have to find the distance between them, that is the distance between the parallel sides, which is essentially the height of the trapezium. We have to find h. So this is also centimeter square. So this will imply 1080 is equal to 35 plus 55 is 90, 90 by 2 h. This implies h is equal to 2 multiplied by 1080 divided by 90. This is equal to 24 centimeter. So h is the height of the trapezium is 24 centimeter. Question number 4 is 18. This is exercise 18A. 4 is 24 centimeter. Okay. Let's do question number 5. A field is in the form of a trapezium. Its area is 1586 meter square and the distance between its parallel side is 26 meter. If one of the parallel side is 84 meter, find the other. Okay. This is also straightforward question. We know that area is equal to half multiplied by the sum of the parallel sides multiplied by the height. The area, question number 5, the area is given as 1586 meter square is equal to half multiplied by and the distance between its parallel side is 26 meter. So the height is given as 26 meter. Height is given as 26 meter. If one of the parallel side is 84 meter, so let's say x is 84 meter. So let x be equal to, we don't know whether x or y will be 84 meter. Let's assume x be 84 meter. So we have 84 plus y multiplied by the distance and the distance between its parallel side is 26 meter, that is the height is 26 meter. So we have this meter square. So this will imply 15, if we ignore the meter square, we have 1586 is equal to 84 plus y multiplied by 26 divided by 2, which is equal to okay, we have this. So we see this is a linear equation in y, and we can easily solve for y. So this will imply 84 plus y will be equal to 2 multiplied by 1586 divided by 26. 2 divides 26 with 13, and 13 divides 1586 with 1, 28, 2, 26, 2. So 84 plus y is 122. So this implies y is 122 minus 84, which is equal to 8, 12, 9, 3, 38 meter. So basically the other side, other parallel side is 38 meter, which is smaller. So our assumption was wrong, that actually x is as per our discussion in the theoretical videos, I always consider x, I always denote the smaller parallel side as x and the larger parallel side as y. So in this problem x is actually 38 meter and y is 84 meter. Y is 84 meter. So the length of the parallel sides are 38 and 84 meter. 38 meter. Okay. So one parallel side was given as 84 meter. The question was asking about the other parallel side, length of the other parallel side, which is 38 meter. So 38 meter is the answer. Okay. Let's see question number 6. The area of a trapezium is 405 centimeter square. Its parallel sides are in the ratio 4:5 and the distance between them is 18 centimeter. Find the length of each of the parallel sides. Okay. Question number 6. The area is given. Area is given as 405 centimeter square. The ratio, the parallel sides are in the ratio 4:5. So definitely we can say let so we have x is to y is given as 4:5. So let x be equal to 40, and you know from the concept of ratio and proportion, whenever you have to solve the value of some quantities whose ratio are given, we always, based on the parts of the ratio, we always assume the value of the quantities as a some multiple of the some variable, unknown variable. In this problem I am considering it as t, multiple of t. So x, let's say x be 40 and y equals to 5t. Okay. The ratio of the parallel sides is given and the distance between them is given, that is height is given as 18 centimeter. Okay. Now, so this implies area will be equal to half multiplied by x plus y multiplied by h. So h is given as 18 centimeter. The distance between the parallel side is the height of the trapezium, which is given as 18 centimeter. The area is also given as 405 centimeter square. So we have 405 centimeter square is equal to half multiplied by what is x? X is 40 and y is 5t multiplied by h is 18. So we have this much centimeter square. Ignoring the units, we have 405 is equal to 40 plus 90 is 40 plus 50 is 90. We have 90 multiplied by 18 divided by 2. From here we can easily solve for t. So t will be equal to 2 multiplied by 405 divided by 9 multiplied by 18. Okay, so we have 2 divides 18 with 9 and 9 divides 40 with 4, 36, 5 and 5. So t is equal to 5. So this implies x is equal to 40, that is 4 multiplied by 5 centimeter, which is equal to 20 centimeter, and y is equal to 5t, that is 5 multiplied by 5 centimeter, which is equal to 25 centimeter. So the question was asking find the length of each of the parallel sides. So the length of the parallel sides are 20 centimeter and 25 centimeter. Question number 6, the answer is 20 centimeter and 25 centimeter. Okay. Let's do the next problem. Question number 7, the area of a trapezium is 180 centimeter square and its height is 9 centimeter. If one of the parallel sides is longer than the other by 6 centimeter, find the two parallel sides. Okay. So let the parallel sides are x centimeter, and so one parallel side is 6 centimeter longer than the other. So the other side, if the smaller parallel side, if the length of the smaller parallel side is x centimeter, the length of the longer parallel side will be x plus 6 centimeter. Okay. So we have area will be equal to half multiplied by the sum of the parallel sides, which is x plus 6 multiplied by height. The height is given as 9 centimeter. So we have 9. This much centimeter square. This implies area is given as a 180 centimeter square. So we have 180 centimeter square is equal to half multiplied by x plus 6 is 2x plus 6, and we have multiplied by 9 this much centimeter square. Ignoring the units centimeter square, we have 180 is equal to 9 multiplied by 2x plus 6 divided by 2. On the simplifying the right hand side, we can cancel out 2. So 2x plus 6 we can factor out 2, and we have x plus 3 divided by 2. This is equal to 9 into x plus 3. So we have a linear equation in x. We can easily solve for x. So we have 180 is equal to 9x. We have 180 is equal to 9 into x plus 3. We can to simplify the equation, we can divide both sides by 9, and we have 20 is equal to x plus 3. So this implies x is equal to 20 minus 3, that is 17 centimeter. X is 70 centimeter. So this implies parallel sides are of length 17 centimeter and 17 plus 6 or 23 centimeter. So 17 centimeter and 23 centimeter are the length of the parallel sides. Okay. Let's see the question number 8. In a trapezium shaped field, one of the parallel sides is twice the other. If the area of the field is 9450 meter square and the perpendicular distance between the two parallel sides is 84 meter, find the length of the longer of the parallel sides. Okay. Question number 8. So it is given that area is given and one of the parallel sides is twice the other. Okay. So we have, so let the parallel sides be of length, the unit is given in meter, so x meter and twice x meter. Since it is given that one parallel side is twice the length of the other parallel side, we are considering that the length of the smaller parallel side is x meter and the length of the larger parallel side or the longer parallel side is 2x meter. So we will have the area will be equal to half multiplied by the sum of the parallel sides, that is x plus twice x, multiplied by the height. The height of the trapezium is given as that is the distance between the two parallel sides is given as 84 meter, which is the height of the trapezium. So we have 84. So this implies the area of the trapezium is given as 9450. So 9450 is equal to x plus 2x is 3x multiplied by 84 divided by 2. So we have a linear equation in x. So x, if we solve for x will be equal to 2 multiplied by 9450 divided by 3 multiplied by 84. Okay. So 3 divides 9450 with 3 and 3150. 2 divides 84 with 42 and 42 divides okay, so 3 divides for 42 with 14. 3 divides 3150 with 1050 and 7 divides 14 with 2, 7 divides 1050 with 150 and 2 divides 150 with 125. So x is equal to 125 meter. So the problem is asking the length of the longer side. So this implies length of longer parallel side is equal to twice x meter, which is equal to 2 into x is 125, this much meter, which is equal to 250 meter. So the length of the longer parallel side is 250 meter. Question number 8. Why the answer is 150 meter? Why? X plus twice x, 3x multiplied by 84 by 2. So x is 2 multiplied by 9450 divided by 3 multiplied by 84. 3 cancels 9450 with 3. 150. Okay, 2 cancels, 84 with 42, and then 7 cancels, 2 again cancels, 42 with 14, 2 cancels, 3 1, no, 3 cancels, 42 with 14, and 3 cancels, 3150 with 1050. Okay, 7 cancels, 14 with 2, 7 cancels, 1050 with 150, 125. So x is 125. Find the length of the longer parallel sides. The longer parallel sides will be 2x meter, which is 2 multiplied by 125, which is 250 meter. I don't know why the answer is given as 150 meter. Why? If it is 150 meter, the next will come as 75. X will come as 75. It is wrong. In a trapezium field, one of the parallel side is twice the other. If the area of the field is 9450, the height is 84. Okay. X plus twice and 3x, 84. I will quickly use the calculator to see what is the value of I might be doing some calculation mistake. What is the value of x? X will be 9450 multiplied by 2 divided by 3 divided by 84, which is 75. Oh, sorry, my mistake. It is 75 actually. I don't know. This is actually 75. Should be 75. Oh, sorry. 2 divides 150 with not 125 but 75. Okay. So this is 75. And the length of the longer parallel side is 75 multiplied by 2, which is 150 meter. Okay, let's do the next problem. Question number 9. The length of the fence of a trapezium shaped field ABCD is a figure is given. Okay, so let's quickly draw the figure. This is question number 9. The figure is okay. So we can see it is something like this. Trapezium. A, B, it is A, B, C, D is the trapezium field, trapezium shaped field where AB is perpendicular to BC and AD is parallel to BC. Okay. The length of the fence of a trapezium shaped field ABCD is 130 meter. So this means that the perimeter, the length of the fence, there is a fence whose shape is like the trapezium, and the total length of the fence is 130 meter, which means the perimeter of the trapezium is 130 meter. Okay, so perimeter is 130 meter. What else is given? And side AB is perpendicular to each of the parallel sides AD and BC. Okay, if BC is 54 meter, BC is 54 meter, and CD is 19 meter, and AD is 42 meter. AD is 42 meter. Find the area of the field. Okay. So, this is given. AD is 42 meter. BC is 54 meter. So the smaller parallel side, its length is 42 meter. The length of the larger parallel side is 54 meter. And what is given? CD is given. CD is given. Okay. CD is given. We need the height. We know the length of the parallel sides. We just need the height. So let's say DE. If DE is perpendicular to DE is perpendicular to BC, will imply height H will be equal to DE, which will also be equal to AB. Okay, fine. And also we will have, since DE AB is perpendicular to BC and DE is also perpendicular to BC. So this implies that AB and DE will be parallel. So this implies that ADEB is a square, is a rectangle. ADEB will be a parallelogram, since the opposite sides, AD is parallel to BE and DE is parallel to AB. And one angle, as we can see, one angle, that is the angle B, is 90 degree. So in a parallelogram, if one angle is 90 degree, all the angles are 90 degree, which means it will be a rectangle. So ADEB is a rectangle. This means that BE will be equal to AD, will be equal to 42 meter. Now consider the right angle triangle. Okay, so we need the H. This is H. In right angled triangle DC, applying Pythagoras theorem, we will have DC square will be equal to DE square plus EC square. Now what is DC square? DC is given as 19. So 19 square will be equal to DE is H, it is the height of the trapezium. So let's say this is H. So we have H square plus what is EC square? EC square is nothing but what? EC is BC minus BE. EC is BC minus BE. So B square. This implies 19 square is equal to H square plus what is BC minus BE? BC minus BE is 54 minus BE is 42 is square. So we have to find the value of H from this equation. 19 square is equal to H square plus 54 minus 42 is how much? Is 12 square. Now this means H square is equal to 19 square minus 12 square. Using the formula of A square minus B square, A square minus B square, we get this will be 19 minus 12 multiplied by 19 plus 12. This is equal to 19 minus 12 is 7 and 19 plus 12 is 31. What is this? H is not coming to be a find the area of the field. H is not coming to be a, H will not be a perfect square. H square is not coming to be a perfect square. 7 into 31 is not a perfect square. Let me see if I done the calculation correct or not. Okay, so perimeter was given. Perimeter was given. Why even I am trying to find the height H? The perimeter was given. So from the perimeter, we can easily find AB. AB is the height of the trapezium. So all this part is not required. Sorry. It is very, very essential that you read, that you have read the problem carefully and what all information has been given. So clearly perimeter is given. So we know that perimeter P will be equal to AB plus BC, that is the length of all the sides, length of the four sides, CD, and AB plus BC plus CD plus AD. This implies perimeter is given as 130 meter. So we have 130 equal to what is AB? AB we don't know. AB is basically the height. As you can see, AB is perpendicular to BC. So basically AB is the perpendicular distance between the parallel sides AD and BC. So AB will be the height of the trapezium. So AB is nothing but height. And what is BC? BC is 54. 54. And what is CD? CD is 19 and AD is 42. So 19 plus 42. So this implies 130 is equal to H plus 54 plus 19 plus 42 is 15, 115. So this implies H is equal to 130 minus 115. This is equal to 15 meter. So this implies area will be equal to half multiplied by the sum of the parallel sides, that is AD plus BE, AD plus BC, AD plus BC multiplied by H. Half multiplied by what is AD? AD is 42 and BC is 54 and height is 15. This much meter square. 42 plus 54 is 96. 96 multiplied by 15 divided by 2 meter square. This is 48 multiplied by 15 meter square. This is equal to 48 multiplied by 15, 240 multiplied by 48, 0. So this is 720 meter square. So the area of the field is 720 meter square, which is correct. So the perimeter was given, and the side AB, since AB was perpendicular to the parallel sides AD and BC, so AB is the height, and the length of the all other sides were given, so we can easily find the length of the side AB, which is the height. Okay, let's do the next problem. So there is a figure. Let's draw the figure first. So this is question number 10. Question number 10. Let's draw the figure. Okay, so we have A, B, C, D. So AB is perpendicular to BC. Okay, AB, C, D. A, B, C, D. A, B, C, D. AB is perpendicular to BC. So in the given figure, ABCD is a trapezium in which AD is parallel to BC. So AD is parallel to BC, and it is given angle ABC is 90 degree. So basically AB is perpendicular to BC. AB is perpendicular to BC. So this implies height is equal to AB. AB is the height, and AD is given as this side 16 centimeter. AC is given as AC. Oh, one diagonal AC. This is given as 41 centimeter. 41 centimeter, and BC is given as 40 centimeter. BC. Okay. 40 centimeter. So we have the length of the two parallel sides. We don't know the height, that is AB, but the length of the diagonal is given AC. Now, so what is asking? It is asking find the area of the trapezium. Okay. So we can clearly see that in triangle, in right angle triangle ABC, we have AC square is equal to AB square plus BC square. This implies what is AC is given as 41 square. AC is 41 centimeter. So 41 square. AB is the height of the trapezium, that is h square, plus BC is 40. So 40 square. This implies h square is equal to 41 square minus 40 square. This is equal to 41 minus 40 multiplied by 41 plus 40. This is equal to 81. So this implies h is equal to square root of 81, which is 9 centimeter. So the height is 9 centimeter. So now we can easily find the area of the trapezium, as we already know the length of the parallel sides. So area is equal to half multiplied by the sum of the parallel sides, that is 16 plus 40 multiplied by the height, which is 9, this much centimeter square. So this is equal to 16 plus 40 is 56. 56 multiplied by 9 divided by 2 centimeter square. So 2 divides 56 with 28. So this is equal to 72 to 52 centimeter square. Question number 10 is 252 centimeter square. Okay, let's do the last problem. Oh, there are two more problems. Okay. Question number 11. The parallel sides of a trapezium are 20 centimeter and 10 centimeter. Its non-parallel sides are both equal, each being 13 centimeter. Find the area of the trapezium. So this is an isosceles trapezium, since the non-parallel sides are equal. Okay. So we have x, the smaller parallel side is 10 centimeter. Y is the longer parallel side is 20 centimeter, and I denote the length of the equal non-parallel sides in an isosceles trapezium with the letter D. So D is given as 13 centimeter. So if the isosceles trapezium is like this, as per my theoretical discussion, let's say A, B, C, D, AD and BC are the non-parallel equal sides. I denote their length with D, small d, and AB is X and DC is Y. Okay. So we have X equals to 10, Y equals to 20 and D is equal to 13 centimeter. This is given. We have to find the area of the trapezium. Now we know that in an isosceles trapezium, we can easily find the height of the trapezium. That is, if BE is perpendicular to DC, so BE will be the height of the trapezium. We know that we have a formula for H. In an isosceles trapezium, if H is the height and X and Y are the length of the parallel sides and D is the length of the non-equal parallel sides, we have H square is equal to square root of D square minus Y minus X by 2 whole square. You can watch my video on how to find the area of an isosceles trapezium, where I have discussed this formula. Okay, so we have this. So what will be the, from we know D, we know X and Y, so we can easily find what is H. So D square, D is 13 square, Y minus X by 2. What is Y? Y is 20 minus 10 by 2 square. This is equal to square root of 13 square is 169. I hope it is 169. Yes, 169. And 20 minus 10 is 10. 10 by 2 is 5. 25. So this is square root of 144, which is 12. This is not H square but H. The formula is H square is equal to D square minus Y minus X by 2 whole square. So H will be square root of D square minus Y minus X by 2 whole square. So we have H is equal to 12 centimeter. So now we can easily find the area. This implies area will be equal to half multiplied by X plus Y multiplied by H, this much centimeter square. This is equal to half, X is 10, Y is 20 and H is 12. This is 30 by 2 multiplied by 12 centimeter square, and this is 180 centimeter square. So the area of the trapezium is 180 centimeter square. Okay, let's do the final problem, that is question number 12. The parallel sides, question number 12. The parallel sides of a trapezium are 25 centimeter and 11 centimeter, while its non-parallel sides are 15 centimeter and 13 centimeter. Find the area of the trapezium. So we are given the length of all the sides of a trapezium, and we have to find its area. So this we have to use the Heron's formula. Okay, by the way, in my previous videos I have turned the formula for finding the area of a triangle based on the length of its sides as Heron's formula. Actually it is Heron's formula. Quite surprisingly, in the book of author RS Aggarwal, it was written as Heron's formula, but it is actually Heron's formula, which is that area of a triangle, if we have a triangle with the sides ABC, the length of the sides of a triangle is ABC, then the area will be equal to square root of small s multiplied by small s minus a multiplied by small s minus b multiplied by small s minus c, where the small s is a semi-perimeter, that is the half of the perimeter of the triangle, and the perimeter of the triangle is a plus b plus c. So small s is half of a plus b plus c. We have to use this formula. Okay, how do we use this formula? Again, I have you can watch my video where I have discussed about how to find the area of a trapezium from the length of all its sides. So basically what we do is, let's say this is the trapezium, this is the trapezium, A, B, C, D. The parallel sides are given as 25 centimeter and 11 centimeter. So this is 11 centimeter, this is 25 centimeter, and the length of the non-parallel sides are 15 centimeter and 13 centimeter. So let's say this is 13 centimeter and this is 15 centimeter. So how do we apply the Heron's formula to find the area of the trapezium? So from the vertex B of the trapezium, I will draw a parallel line parallel to AD, a line parallel to AD. Let's say this is BE. So BE is parallel to AD. So ABED will be a parallelogram. We already have AB parallel to DE. So ABED will be a parallelogram, and hence we will have BE will be equal to AD, and AD is given as 13 centimeter. So by drawing this line parallel to AD, we have constructed the triangle BEC. That is the main objective, to construct a triangle BEC so that the height of the triangle will be the same as the height of the trapezium. So if I draw a perpendicular from B to DC, is say this BF, then BF will be the height of the triangle BEC as well as the trapezium ABCD. Let's say denote the height, length of the height as the small letter h. Now the idea is that in the triangle BEC we will get the length of all the sides. So BE is 13 centimeter, BC is already given as one of the non-parallel sides, which is 15 centimeter. What is EC? EC will be equal to DC minus DE. DC we already know as 25 centimeter minus DE. DE will be equal to AB, which is 11. So EC will be 14 centimeter. So in the triangle BEC, we know all the length of all its sides, and so we can clearly find its area using the Heron's formula. So we will find the area using the Heron's formula. Also we can find the area of the triangle BEC using the base EC and the height h. So we will equate the two area. So let's find the area of the triangle, area of triangle BEC. But before that, let's find what is the semi-perimeter. So in triangle BEC, the semi-perimeter small s is half multiplied by BE, that is the perimeter of the triangle, BE the sum of the length of its sides, BE plus EC plus BC, which is equal to half multiplied by what is BE? BE is 13, EC is 14 and BC is 15, this much centimeter. This is equal to 13 plus 14 is 17, 17 plus 15 is 32, 32 by 2 centimeter, which is equal to 16 centimeter. Yes, semi-perimeter is 16 centimeter. So this implies area of triangle BEC will be equal to square root of, using the Heron's formula, square root of small s multiplied by small s minus BE, small s minus EC, smallest minus BC. This is equal to AC 16, and we have 16 minus BE is 13, and 16 minus EC is 14, and we have 16 minus BC is 15. So this is equal to square root of 16 multiplied by 3 multiplied by 2 multiplied by 1. So this is equal to it is not coming perfect square. 16 multiplied by 3 multiplied by 2 multiplied by 1. 3 into 2. Okay, fine. So this is how much? This is 4 and square root of 6. This much centimeter square. So area of the triangle BEC is 4 into root 6 centimeter square. Let me quickly check if I did the calculation correct or not. The length of the parallel sides are 25 and 11. Okay. While its non-parallel sides are 15 and 13. 15 and 13. Okay. Okay. So BE will be equal to 13 centimeter. BC is equal to 15 centimeter. EC is equal to DC minus DE, which is DE will be 11 centimeter. So DC is 25 minus 11. Okay. So the base of the triangle will always be the difference of the parallel sides, which is 25 minus 11, and which is 14 centimeter. Okay. So the semi perimeter S will be half BE plus EC plus BC. What is BE? BE is 13 centimeter, EC is 14 centimeter, and BC is 15 centimeter. Okay, so this is equal to 13 plus 14 plus 15 is 27 plus 27 plus 27 plus 15 is 42. So this is where I made the mistake. This is 42. So this will be 21. S is 21. So this is all wrong. 21, 21, 21, 21. So this will be equal to 21 multiplied by 8 multiplied by 7 multiplied by 6. Let's see if we can form a perfect square inside the square root. 21 is 7 into 3. We have 8. 8 is 4 into 2. And we have 7, and we have 6 is 2 into 3. So this is equal to, we have 7 into 7, and then we have 3 into 3, and finally we have 4 into 4. So this is equal to 7 into 3 into 4, which is 84 centimeter square. So the area of the triangle BEC is 84 centimeter square. Also, the area of the triangle BEC will also be the half the height. The height we are assuming, the height of the triangle BEC, which is BF, is also the height of the trapezium ABCD. So height multiplied by the base of the triangle BEC will be EC. EC, which is equal to height by 2 multiplied by EC. Base of the triangle is nothing but the difference of the parallel side of the trapezium. So 25 minus 11, which is equal to 14h by 2, which is equal to 7h. So this implies, using the Heron's formula, we have found the area of the triangle BEC to be 84 centimeter square, and also using the half into base into altitude formula, we have found the area of the triangle BC as 7h. So this implies the two areas must be equal. So 7h must be equal to 84. So this implies h is equal to 84 divided by 7, that is 12 centimeter. So the height is we have found to be 12 centimeters, and now we can find the area of the trapezium. Area of trapezium will be equal to half multiplied by AB plus DC plus multiplied by height. So AB and CD are the parallel sides, which is equal to half. AB was 11 and DC was 25 multiplied by the height we have found to be 12. So this much centimeter square. This is 36 multiplied by 12 divided by 6 centimeter square, and this is 72 centimeter square. So the area of the trapezium is 72 centimeter square, and my answer is wrong. Let me see what went wrong. 36 multiplied by, oh, I am prone to make calculation mistake. So this is 36 multiplied by 12 divided by 2 centimeter square. 2 divides 12 with 6. This is equal to 216 centimeters square. This is correct answer. So all the questions of this exercise 18A were pretty straightforward, but please be aware how to find the area of a trapezium where all its sides are given. That is, using the Heron's formula. First you have to find the height of the trapezium, and once you have found the height of the trapezium, you can then find the area of the trapezium, and also how to find the height of an isosceles trapezium using the Pythagoras theorem. So with this, it comes to an end in solving the problems of exercise 18A. All these problems were based on finding the area of a trapezium. I hope this video was beneficial. If it is so, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve I will start the next topic, that is how to find the area of polygons, that is regular polygons and irregular polygons, using the concept of area of trapezium, and as well as triangles and rectangles, and primarily how to find the area of a polygon using the formula of area of triangle, rectangle, and trapezium. So please stay tuned for this video coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.